Okay, so here we go with the first video for surfaces of revolution. So we've talked a lot about volumes. How do we find surface area of objects which we revolve around axes? Well, let's talk about it, see if we can figure out the formula. So let's say I have a function from A to B. I want to revolve it around the x-axis. So what is that going to look like? So let me draw the other side. Try it one more time. The peak is like right here. Okay, so I've got this solid that I've generated. How do I find the surface area of it? Well, just like always, I'm going to break it up into as many little tiny pieces as I can, and then add them up. So, let's say I take an x value here, and let's say the thing that I want to draw up is going to be like if I broke up this surface area vertically, these little tiny pieces would kind of look like, I'm going to draw them bigger than they were if they were like infinitely small, but hopefully you can see it's kind of like a band. It's kind of like an armband. It's like a little part that wraps around the shape. So what would be the area of that armband? Well, you can kind of approximate it like a cylinder. These lines are curved, but when these get infinitely small, you really won't be able to tell the difference. So let's think about the area. This is kind of like a cylinder shape. It's kind of like a cylinder, but minus the top and the bottom. It's only like the outside part. So what is the area of one of these? Well, I'm not going to derive the formula for you. I'm going to trust that you remember it, or that if you don't, you'll learn it. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. This is when it includes the top and the bottom. I have pi r squared as the area of the circle, and I got two of them. That's the top and the bottom. And then 2 pi r h is the outside part. This is the only one that I want right now, because I'm not finding the area of this like top circle and this bottom circle. That's not what I'm looking for. So I'm only looking for 2 pi r h, where this is kind of the armband. What's the h and what's the r? Well, the r is the radius of this big circle. That's just the x value. Now, I do know this cylinder has width, so this circle, the front one and the back one are different, but these are going to be infinitely small. You won't be able to tell the difference. So the radius is just the function value. So we don't worry about that. So it'll be 2 pi, the function, and then what's the height of this cylinder? The distance between the two circles. That's this length right here. Isn't that a part of the arc length of the curve? I've drawn it straight, but didn't we figure out the length of a curve by breaking it up into a bunch of little tiny pieces and then adding it up? So what did we add up? We added up the square root of 1 plus dy dx, or f prime, squared. So this is the height. It's this little length right here. So I take all of these armbands, I add them all up between my interval, and that's the formula. It's kind of gross, but what are you going to do? Some of these are. And then in the next couple videos, we'll do some examples. See you then.